First of all, let me introduce myself. My name is Rob Stocklosa, and I'm a application engineer with TPM out of the Raleigh, North Carolina office. And I thought I'd take this opportunity when we needed to put together a webinar to really just show some of the functionality of the multi-body environment within SOLIDWORKS. I've entitled the webinar, Rethink Your Workflow and Process. And I could probably do 5 or 10 webinars on this environment in my mind. So today I'm going to show you a portion of it that I think is applicable to the multi-body and just kind of give you an idea of what you can do with that environment. Maybe it's something that you haven't really thought of in the past, or you might have gone about it a different way. So really the intention of today is to get you thinking next time you have a situation. Instead of the same old process of draw apart and go to our assembly and do all that rigmarole, maybe take a look at the multi-body environment first. And that's really what I'm just trying to get across today, is just get you thinking about the multi-body environment. The tools have been enriched over the years, and the stability of it has increased substantially. Multi-body is not new to 3D modeling. It's been around for some time, and in fact, the Boolean operations that take place behind the scenes, it's some of the first functionality that CAD had ever seen. I think it goes back some point in the late 60s, actually. So it's been around quite a while, but maybe that's why we tend to overshoot it, and we look at the newer functionalities and the cool things that we can do. But sometimes, as with a lot of things in technology, things that have been around a while, that they're proven, they're tried and true, and it's worth taking a look at. So today, the demonstration is going to revolve around the calling that you see on the screen. I'll give you some background on it. It's kind of my little side project that I work on, is working with airplanes, and this came up over the last couple months. We had a challenge to adjust the design of the cowling on our airplane to accommodate some new turbochargers, which required some different airflow characteristics. So it really prompted this whole project. And like I said, it's not a company we deal with. This is just my own kind of side thing. But again, I have introduced this to several companies, and they are taking this information and readily applying it to their own process. So let's get started. Hop in here. So that's the beast. This is a racing plane that I help a buddy of mine who he's the owner, and we have a team of engineers, and we all work together on it, and we all bring something to the table. And this particular model, out of the shop, you can buy this plane. It's called the Lance Air, and it's, for the most part, it's a carbon fiber plane, one of the first of its kind. So there was a lot of structural integrity things that we were looking at, along with the weight, and it was the best option for us to start with. The problem came in when we put this beast of an engine on the you can imagine that it doesn't necessarily come stock out of the manufacturing floor with that kind of an engine in it. So we did have we had some challenges to address. We had our first run on it. We were stuffing things into that cowling in places that it just didn't belong, just to get the plane running. And then when we had some more time, we kind of revisited these issues and really, how did we do it right? On the left, you can see the full plane, and on the right, it's kind of a zoomed-in picture here. But, excuse me, we had these turbochargers. There's 2 of them, and you can see, for those of you that are mechanically inclined, you can guess where these guys go here. But we have our intakes and outtakes, and basically in between that orange pipe and this blower housing over here, that's really where we were fitting in these turbochargers. For those of you that aren't familiar, a turbocharger just basically takes air, sucks it in, compresses it, and throws it into your engine. So now you have that much more compression and that much more, oxygen and that whole ratio. Everything changes with a turbocharger. It gives you lots more power. So we needed it. We wanted to win some races. The problem is we stuck these things in there. We crammed them in at first, and we weren't getting the performance out of it that was required. So that was the overall challenge. Was okay. We got these really cool turbochargers, and we know what they do, and our engine accepts it. Our engine wants them, but we're not giving it enough air. So we ultimately came to the conclusion that we could put Band-Aids on this thing all day long, but we're going to need to redesign the cowling. And you can imagine that was kind of a, oh man, right? That was our last option that we wanted to approach. But I think all of us in the back of our head knew we were going to have to do that at some point. And that's what I'm going to show you is, how did we go about that? You got a couple of garage mechanics, a couple of guys that engineers and electricians and things, and here we were faced with this challenge. We don't have, very high-end equipment. We had a garage, we had a hangar, and we needed to build this thing. So I'll take you through exactly what that looked like and show you some of the models and the processes that we followed. But at the end of the day, the multi-body environment is what really got us out of some jams. It enabled us to take the data that we captured, make changes, understand the effect of those changes. We did some iterations to those to figure out, optimum airflows and angles and things. There was a lot to it. But the multi-body environment allowed us, at the end of the day, not to create the part per se, but to create the tooling that we needed to create the cowling. And that's what I want to that's the change, right? You notice I said we created the tooling, not the part. Now granted, the part, comes out of that. But this is the approach that I would really like to get you guys thinking about is, do you ever even think about the tooling? Do we just make the part and send it on our, through our process and let somebody else figure that out? But for us, we had budgetary constraints, as you guys do, and we had many constraints and as far as manufacturing. I didn't have access to some of the highest end autoclaves and things. So we had to get a little bit creative, but that's what engineers do. We get creative and solve the problem, and we did. So this next slide here just shows you a stock cowling for a Lance Air. And you can see on the bottom here where I was illustrating earlier, this is where those turbos on either side, they were symmetrical, but that's where those turbos resided. So you can imagine the first race, when we crammed everything in there, restricting that airflow, it was prohibitive. We had some heat issues, there was a lot of things that came along with that, but we just weren't given the airflow to the intakes of those turbos that they could handle. So our performance on those, we were probably getting 60–65% of the performance that we could have gotten simply because that thing was gasping for air. So our challenge, again, is to take this cowling that you see here and create the cowling that we needed with these complex blended air intakes. On top of that, we weren't exactly sure what air intake to go with. So we actually made a modular design where we could kind of like a quick snap, if you will. We could snap in these different air intakes that had these different profiles and radiuses, and we could see the real effect in a real-time physical test. We did use SOLIDWORKS Flow for much of the calculations of cooling the engine and understanding airflows and whatnot. But as with any simulation, just like what I tell you guys when we're working with you, you're really, it's a simulation. That's the word for it. So we really don't know the outcome until we put this into a practical test. And at the end of the day, that's exactly what we were able to do. So, given this was the problem, we were faced with how do we go about this, right? This is just an image of how we got to the moon, actually, is what you're seeing there. That's the calculations it took for some of the trajectories and things back in the Apollo spacecraft. This was not the route we wanted to take. We had a bunch of guys that were very privy to technology. We weren't scared of trying new methodologies. And some of it, was proven, but at the same time, a lot of this we were kind of stepping in, and we had heard this should work, and we heard the folklore that, oh yeah, you do this and you get this, but really until we got into it, we weren't really sure. So needless to say, we thought method one here with the chalkboard and a couple ladders and a bunch of engineers in white shirts and ties, that really wasn't going to work for us. You probably get the solution at the end of the day, but not nearly as fun as, as the experience we had building it. So we decided method one is not going to happen. Let's take a look at a different approach. So the first thing that we did, we weren't really sure exactly what we were going for. We had this, we had this concept in our head, and we knew it needed to look like these little scoops. But there was much more to it. How are we going to blend this thing in? Our biggest goal when we started talking about it was trying to use the existing tooling that we already had. The cowling that was on there, we had tooling for that cowling, and like I said, we were kind of strapped for cash and didn't have many resources, so we really had to figure out, how can I reuse what we have? How do we take the tooling that created that cowling you saw on the original manufactured plane and use that to create, the scoops for the air that we were looking for. So the first step that we had here, I don't see this a lot in what we do, mainly because I think so much of in the mechanical world, it's 90-degree angles, it's perpendicular. It's not, we're not building a Harley Davidson gas tank usually. So the prismatics to our parts, right? It's all 5-axis, 3-axis machines, that type of stuff, and we just don't see the clay models too much. However, I thought this was just a good thing to throw in here. I don't know if any of you do have the capabilities to do this or require it, but I can tell you, going from a clay model, scanning that and doing your work on it, it's a very fluent process. And I'll tell you, I'm not an artist or anything, but you can work with the clay. It takes a little practice, but it does help. And you can see here, without cutting a piece of metal, without doing anything, we kind of whittled out this cowling of what we thought this should look like. And that was it. This was some preliminary design tests and concepts, and we kind of put these together. We had multiple models, or clay models, that we put together, and we just kind of talked about it to figure out what's going to be our best bet. Where do we put these? How do we blend it in? Where do we blend it in? And then we also, in the back of our mind, we're thinking about, how is this going to affect that original tooling? So again, this is not a multi-body thing, but it's something that I don't see too often, and I just thought it would be a great thing to throw in here to give you guys an idea to, maybe you don't do this every day or you haven't seen it, but know that some of these really cool shapes and things you see out there in the world, this is how it starts. Clay models still get the job done. All right, so we're going to hop into SOLIDWORKS here in a moment, but I just want to talk you through the process, all right? The first thing we had, of course, was that clay model, right, which gave us an idea of what we were going for, and we scanned that, and then we scanned the original cowling so that we had, both sets of data. And that's the first thing I want to pop into here, is just to show you that scan of what the original cowling looked like. Where is that guy? Yeah, right there. Okay. So let's go in here, and I'm going to pull up, like I said, that original cowling, just to show you what we were dealing with, really. Okay. So if I go ahead and zoom in here, again, I'll slow down and kind of illustrate. I don't know how familiar you are with this process as well, but when we scan anything, it literally turns that object into millions and millions of points. It's what we call a point cloud. And then from that point cloud, we wrap surfaces, or in this case, I've got some cross-sectional geometry you can see here. We just take that scan data, And it doesn't have to be perfect. You can see we missed a few spots, but you know, all in all, we got what we needed out of it. So we were able to scan this, scan the cowling, bring the point cloud in. In our case, we didn't wrap surfaces to it, but we actually generated a 3D model from this point cloud, you know, using some pretty straightforward lock commands and sweeps and things of that nature. But you can see there, we were just capturing each cross-section throughout that point cloud, and it gave us a very accurate representation of the cowling as it was today. So it was a really quick way. I think we did this in a couple hours from the time we scanned it till we brought it in. Processing the data probably took the longest, but once we brought it in, it was really quick and simple to create a 3D model from that data. So now we had, you know, we had the actual 3D data of the existing design, and we had this clay model that we scanned as well and did some manipulating within SOLIDWORKS with that. So within a day, really, we had the existing data and we had the new data that we were trying to go to. So really the question at that point became, what's the delta, right? How do we get from this to that? And that's where we use the multi-body environment. So if I just take a look back over here at our PowerPoint, we did that scan, right? We had that clay conceptual model, and then we popped over here to this multi-body environment. And I'll show you how we utilize that. All right, so I'm going to go ahead and open up one of our versions. All right, and you can see, and all I want to show you here is you guys are not alone. All right, this was my first crack at this. I brought this data in, and I tried to put these intakes on there. And I just want you to know, it's not as easy as you think, and it definitely was not any easier for me. It was a very, very tricky set of geometry to get correct. The other part to this, like I mentioned, is we wanted to have these kind of snap intakes where we could test out different profiles. So in this case, you can see that snap kind of quick change intake is that red body there. And that's what I started going for, you know. I started to build this up. I took that clay data and I started to understand how this was going to kind of diverge from the original shape. And then I started playing around with, well, how am I going to get these pieces to snap in place? And again, you know, this was my first run at it, and you can see it's a little messy, you know. So my first approach was I started looking at surfacing. I tried to do it in solids. I tried to do the traditional approach, really. I was trying to create the geometry and get it to intercept correctly where I could manipulate it and, you know, tweak little radiuses here and there. And it became very cumbersome. It was just too complex. I couldn't get the switching and the changes out that I wanted efficiently. Because we were iterating the design, you know, every time we come up with even a small change a radius from a 1/2 inch to a 1/4 inch. Man, you know, you guys have been there. I'm no different. That should be quick, and it wasn't. You know, changing that radius caused multiple parent-child issues. So I quickly realized, you know what, I'm probably going to have to drop back and punt on this one. That's not going to work. So what we did is now I'll go ahead and show you where we actually took these two in here. Let's bring up 4. Oops. Okay, so you can see these intakes are much more fluent. They're much more prismatic. And if I take a look just kind of at a front view here, you can see how it is symmetric. But even symmetry, doing the mirror command, you can't always bet on that. You know, there's a lot of complex blends there, so even mirroring one of those bodies over from left to right, that can pose some problems. So ultimately, at the end of the day, what I did here is I created a multi-body solid. And for those of you that aren't familiar with that, a multi-body environment or a multi-body solid, it's one part, Okay, so I'm in a one-part file. This is not an assembly. And I'm able to either insert, you can actually insert parts, right? I can insert a part into a part. It's basically, that's a process we do. You know, you'll get a message about a derived part, but don't be freaked out. Just learn about it and understand, you know, what this is asking. So we can import a part on a part, otherwise known as a body. Okay, so when I bring those two together, what we ultimately end up is multiple bodies in our one part. And what I've done here, you can just see, you know, we had some of the base for the tooling and what we were originally looking at. These are all just shut off. We had some options in there for the through hole, right, that I can turn on or off at will. So when you talk about iterative design, I really have all these bodies available, and depending on what I'm trying to go for, I can turn on and off, you know, each one of these and show a different version of it. So you can see here, I'm just shutting off that main calling. You know, there's some intakes that I was playing with. So it allowed me to create lots of different iterations and versions of this without, you know, when I made a change, it wasn't affecting that original version. So I could always go back to that. It was kind of my default, you know, setup. I could always go back to it and add to it and make subtle changes, but it was very quick and efficient. As opposed to what I showed you earlier, where I was manipulating lofts and all kinds of stuff, and the parent-child things were affecting me. So I was able to create these independent bodies. And the other thing I'd point out here, when you are creating any type of solid, when you do, let's see here, what do we got? Trying to find one I can show you, maybe like a loft. Right, so one of the things that I point out here is these merge options. Whenever you're extruding, you know, this was a loft, but if you do an extrusion, anytime I extrude these things, I have the availability as the modeler to tell this program how I want it to handle that data. So by merging data, right, it's going to tell it that this is all one solid. This is kind of cut out of one piece of metal. So many of the functions that I used here, one of the key steps to this was to uncheck these merge options. And again, they'll vary in your dialogue, but just to understand what they do. When we have merge selected, it thinks this is cut out of one, you know, big chunk of metal, if you will. So by unselecting merge, it's going to create these independent bodies that you saw up here. And now I have this full control where I can turn on and off what I need, you know, on a whim. So this was one option that we looked at. You know, this was the fourth intake option, and I think we ended up with about 6 of these, but they were all created using this method. Turn on this, turn off that, and then I do a file save as, and I create a different version of it. And you can see that here. You know, I had all these different versions in it. So here's like the 5th version. All right, it's slightly different. You might not be able to tell, but these intakes are a little bit different. But again, I was able to create all these versions very, very quickly. We discussed it as a design team. I utilized all these in SOLIDWORKS flow simulation, which that's a whole nother webinar, if you will. I'd love to show you that, but that was the next step. Once we had these concepts down, we took them in, we did some analysis on it to understand how it's going to perform. And then based off that, based off the analysis findings, we as engineers decided which were the 2 options we were going to go with and create the tooling for. So I'll show you how we created that. But the first step to this was simply being able to quickly create these different versions of this very complex geometry without having the parent-child relationships that we typically deal with affected. When things went wrong, I just turn it off and turn something else on. And it's really that simple, guys. So this is definitely a better option than trying to put all of these iterations into one file. Okay? So once I had a few of these together and we decided which way we were going to go, then I'm going to go back here and show you where we actually start merging these things. Okay? Move this out of the way. So you'll notice here, well, in fact, let me just show you so you get some idea. So you can see the difference, right, in this flat face from what you see in the final model. The flat face that we're representing up here, we are going to cut that out. We did cut that out, but that was where we created these quick connect options so that we could snap in the different air intake modules, if you will. So what you see in the green part, that was ultimately what I was going for, because every intake module I created it using this multi-body method, but we kind of separate that, right? I just take that one body of this air intake, I bring it its own part, we made that, and then we could kind of quick snap these in and do different tests. So it worked out really good, but this green model, that's the one that we really wanted to make. This is the actual finished cowling that we were trying to go for. And you know, I don't know how familiar you are with the manufacturing. This does not turn out to be a solid. It's got a wall thickness to it. So you know, take that with a grain of salt. We did cut some of these holes out, you know, after the fact for the spinner and the air intakes and things. But really, this was the item we wanted. And now I needed to get that tooling. So this is where we use the multi-body Boolean operation that I mentioned earlier. Okay, so I'm going to go in here, and I'm just going to show you that I have a body in this called original shape, right? And if I go ahead and turn that guy on, come here, sucker. All right, you can see how I've overlaid the two bodies on one another. So again, let's take a look at what I have here, because it's a little bit hard to see. I'm going to shut off the original. I'm going to shut off the new one and show you the original, right? This is that original calling. It had no air intakes in it. And that's the tool that we had. That's what we had available to us. We created the new, you know, highfalutin, super smooth surface, new air intake calling, and I overlay the two together. And you can kind of see where those two overlap, right? So for me, all I needed at this point, once we understood what this needed to look like and how we were going to go about it, the next step was to simply get it to my CNC guys. That was not me. That was another set of personnel. But I needed to get them the data so that they could program the CNC to simply cut out, or if you will, open up only the delta that we needed, right? We were reusing that existing tool, and we needed to cut out only what was required. And that's what this tool did for me. I was able to come in here, and you can take this to however step you want. You can remove these bodies from one another, do subtract operations, right? So I can highlight them, and I can say combine them, and we can add, subtract, or keep the common information. And this is exactly how we went about it. It is a little bit of a lengthy calculation, so I'm not going to hit OK there, but basically that's what we did. We took the original calling, overlaid the new calling on it, and then had SOLIDWORKS tell me the difference between it. And you can imagine the difference all was in that one area right here, right, where these air intakes took place. We didn't change the back end, and that was critical. You know, we didn't want to touch that because it was already there. So we really focused in mainly on that area up front, and the delta that we got out of it was a small chunk. It was very complex shape, but we were able to extract that out of this, and then we created some very quick, sent that over to the CNC, and we had a great machinist who was able to go in there and manipulate the existing G-code to cut out only that area that we needed. So at the end of the day, we ended up having taking the existing tooling that we had, and you know, for a very small amount of time investment and money investment, we were able to create, based off that tooling, the new stuff that we needed to create these air intakes. The second step, of course, would be that the actual snap-in values that we looked at. So again, back over here in our PowerPoint, oh, you know what? I thought I had a picture of it in there, but I don't. Let me show you a picture of that, those air intakes. And let's see. So this was one we messed with, but they were very similar to this. All of them changed slightly, and you can see they are actually carbon fiber. We were able to make them out of carbon fiber, and they just snap and click right into those air intakes, and they give us different profiles. So we had about 4 or 5 of these we created on top of that. But everything you see here, guys, came from that original scan and that clay model we created. I was able to do all this, and I'm not kidding. I'm not exaggerating one bit when I say that from beginning to end, this was about a day-and-a-half process. And this this is not even a full-time thing, but through one weekend, we kind of put some effort into it, and within a weekend, we had this all finished, and the cowling was actually, the new cowling was back in our shop Monday morning, and they were fitting it on and doing trials. So it was a super, super fast process to get through that, and very accurate. And for me, it was fun. It was not, you know, those first trials that I had trying to do surfaces and things, I was a little frustrated. But once I got past that and I identified the right way to do it, this made it a really fun project. And as you guys know, with all 3D modeling, the solution tends to bubble up when you put this stuff on the screen. As an engineer, you start to see the solutions, and you just accommodate. You know, I started noticing things as I was building it, and I'm like, oh yeah, man, and we can do that, and you know, that radius was already there, and now I don't have to cut that. So it helps immensely on all avenues. But like I said, I just wanted to give you an idea of the multi-body environment, how powerful that can be. But also, there's a few other nice little tips in there that I hope you can somehow, you know, incorporate into your work. So to recap kind of what we did here, we had the original scan that came from that original calling. You know, scanning devices, they're more commonplace now than they used to be. We can definitely help you if this is something you're interested in, or this process. We do this process. We help companies get set up on this process. That's what we do. So, you know, we are not partial to a specific vendor. We look at all the scanners. We understand what your needs are, and we help recommend the best scanner for your situation. Clay models, again, something I don't see as much of, but I tell you, man, what a quick, awesome way it was to create that concept and get it on the screen, and then, you know, tweak it within SOLIDWORKS. I mean, this came out to be a very finely tuned, high tolerance piece, and it started with that piece of clay you see there. And then the last step that kind of brought it all together was to overlay those 2 sets of data and use SOLIDWORKS to help me understand what the difference was. And then from that information, we were able to get that to our CNC and have the machinist cut out the tooling appropriately. So hopefully that gives you a little bit of a different spin on what multi-body can be used for. Like I said, to me, I could do a whole set of webinars on multi-body. I think it's a phenomenal environment for many different things. But the traditional draw apart and then assemble it and deal with, you know, all the degrees of freedom, not to mention the data management involved in that process. Multi-body kind of changes that. I mean, even what you saw here, you know, I'm dealing with a handful of files, and that's not hard to manage. So I do encourage you to look at it. Feel free to reach out to any of us here at, you know, TPM, whether you're down in South Carolina, North Carolina, or somewhere in between. We're all pretty well versed in this information, and we'd love to have a conversation that we do this. And I hope you all found some information in here that was helpful. And if you ever decide to build your own plane, now you know how to build a cowling that can accept turbos that make your plane ridiculously fast. So just to give you an idea, that plane with the internal combustion engine, that is not a turbine, an internal combustion engine, just like your car, that thing came off the line and was doing 180 knots, and when we race it, we're well into the 420 knot range. That's pretty good for internal combustion. So it's amazing what happens when you squeeze air and blow it up. But anyways, I hope you guys enjoyed it and it was informative. Again, thank you for your time, and please reach out to us if you have any questions.